Hello to everybody. This is Anton Fedosiev, content strategist at Autodesk. Welcome to today's virtual meetup for mechanical engineers. And today's topic is product simulation. Great topic, and I have two great speakers. First speaker is Rahul Patil. He's a product manager on our simulation team. Hey, Rahul. Hey, welcome to the call. Thank you for joining today.
Thank you for having me.
And also we have Michael Fiedler, incredible designated support specialist and engineer who created a couple of great e-learning courses that we're going to discuss today as well. Hey, Mike.
Hello.
Okay, so welcome everybody. Before we jump to the main agenda, let's talk a little bit about the some of the housekeeping rules and how we run webinars in general. Can you see my screen?
Yeah.
I can, Anton.
Excellent. Okay, excellent. Let's jump into it. All right, so all lines are muted at the moment because we are recording this session and it's going to be available to you in a couple of days from now. If you have a question, just use a question box and type it, or in the very end, we can unmute you and you can just, speak to us to test the Q&A panel and also to kind of just check the geography of this webinar today. If you don't mind, can you just type in question mark your name and the place you're connected from? In my case, it's Portland, Oregon. So let's get started and make a quick test. Then, like, what is mechanical engineering meetup in general? So it's a recurring webinar that happens every second Thursday of each month, which means that today is Thursday, 8 a.m. It happens every month on the same day. And we have a rotation of topics. So this time is simulation. The previous one was factory design. And we always try to have somebody from customer success organization and then also from product management team. It's a part of larger initiative for mechanical engineers. The other webinar series that we have is a generative design for manufacturing. And Michael happens to be the host of this webinar, so it's great to have him here today. And this mechanical engineering meetups, they are actually a part of much larger series. So we try to host webinar virtual meetups for other professions as well. And we have architects, civil engineers, etc. You can see the full list on the screen. So if this is something you're interested in, feel free to join. I will post the links in the chat window. So with that, I'd like to give the stage to Rahul. Okay, so let me stop sharing and change the presenter. Okay, so Rahul, you are product manager on the simulation team. So tell us what's the plan for today? What are you going to cover?
All right. So can you see my screen?
Yes.
Okay, great. So hello everyone. I am Rahul Patil. So I'm the product manager for the simulation products in Autodesk Group. Mainly, I manage the manufacturing simulation products like Moldflow and Helios, as well as structural simulation products like Inventor, Nastran, and Fusion 360 Sim, which are the main products that I'm going to talk about today. So to give you some background about myself, so I'm a mechanical engineer by education. I have done my undergrad in India from Mumbai. Then I worked for around 4 years in manufacturing and oil and gas industries before moving to the States in 2015 for doing my master's. I did my master's in mechanical engineering while specializing in applied FEA and CFD. And that's when I got in touch with Autodesk. They offered me an internship when I was working on a project with them. And I worked with the product management team on simulation mechanical at that point. And then afterwards, after I finished my internship project, they offered me a full-time position as a product manager. So when I started with Autodesk, I started with some research work on different simulation products, and then gradually moved as a product manager for our Modeflow product. And then last year, I took over the product management role for the FEA, mechanical FEA products. So I'm going to talk today about the mechanical FEA products that we have in our portfolio, what capabilities we have, and a quick overview of what's coming. And I'll also give some information on what things we are working on towards the future. So before I dive into the product information, I wanted to quickly give you an overview of what simulation is, why do we use it, and how it is beneficial for a mechanical engineer slash product designer or product engineer. So Anton mentioned to me when he talked about this call that most of the attendees here are mechanical engineers, product designers, product engineers. So I'm I'm hoping most of you will have a good idea of what simulation is, why it's used, and what are the benefits of simulation. You have either used it yourselves in some form or the other, or you have worked with someone who regularly uses mechanical FEA products. So quickly going into what are the benefits of simulation? Why do we use finite element analysis? So there's some key benefits to using simulation. But one of the first things that a user should always understand when they're using a simulation product is to ask the question, what am I trying to achieve out of this simulation? The what question already gives me a lot of answers before I even start my simulation, but it gives me a direction where I want to take the simulation process and what do I want to understand from the results that I'll get by setting up the simulation. So some of the key benefits of using simulation is one, to reduce physical prototypes. So you're essentially mapping the behavior of the part design or the product that you have designed in a virtual environment versus actually creating a physical prototype and then testing it for, say, different loads or different situations that the product might be subject to. So that helps reduce the cost of physical prototypes. You can do those simulations virtually and then understand how the part or product would behave. That also helps you improve your time to market because you don't have to go through the process of creating physical prototypes. You can do these things virtually and understand how your part is going to behave. It also helps you understand which material would be best suited for your part. So you can have a part created with steel, but then which type of steel or which type, if there's any other metal that would be better suited for the part, can help you improve the product functionality by picking the better material of the choices you might have, as well as help you also understand how the product is going to perform in different loading conditions, different situations, on how the product would interact with different parts of its assembly, etc. So there's definitely a lot more benefits of FEA, but these are some of the key things that we provide a lot of value to users through our simulation products. Now, using simulation in design process is a critical part of the whole product development process. As you might have seen this kind of a chart or a similar chart in some form or the other, where as you go through your product development process from conceptualization to design engineering, testing, manufacturing, and actually sending it out in the field, you can you have an idea of how much ability you have to make the changes to the functional capabilities of the product that you're designing. As you go further into these steps, the ability to make affect changes goes on the lower side versus the cost of actually making those changes goes way higher. So if you have some issue that you find out during manufacturing or when the product is actually in the field, the cost of actually making changes is a lot higher than actually addressing those things earlier in the design process. So simulation, for example, in this kind of a product development process fits right in during the conceptualization and design engineering phase. Particularly when you're in the design and engineering phase, that's when you have your part design. You can understand the nature and the behavior of the part by subjecting it to different loads and different boundary conditions, as I mentioned earlier, and understand how the part would behave. And the simulation products will give you a good understanding of the part behavior through a virtual simulation process rather than going through physical prototypes. Now, like I mentioned earlier, whenever you enter a simulation product, whenever you're trying to do a simulation, what are the key questions that you need to ask? So depending on what your product use is going to be, you can look at different questions in different scenarios for your different products. So some of the three key questions that we typically see from our customers are, will my design fail? Can my design be optimized? And how can I get it to the market sooner? So will my design fail is something that is one of the most common use or common applications for using simulation products, basically to understand how will my part perform and will it fail under the different loading conditions, different vibrations of the motions, will it fail over a period of time? So how can I understand the fatigue that will act on the over the product's life? Whether my part would deform or fail in non-linear fashion, how much load can it sustain? Whether a lot of load would put it into a plasticity state, or even in case of parts where there's heat and flow involved, then what kind of thermal loading would affect my part? My part, will my design be able to sustain those thermal loading? The second key question is, can my design be optimized? So if I have an assembly, can I reduce the components in that design? Can I modify the design in such a way that I can consolidate different parts into a single part? Can I test different materials for my part? So you can, with simulation, you can run the simulation for different materials like metals and plastics, and then understand which material gives me the best results for my simulation for my part. Whether I can reduce the weight of the part by using a plastic, which would be strong enough to sustain the loads, or do I need a stronger material like a metal, or do I want to go for something like composites, where it's lightweight, but it's way much stronger. It also can help me understand how we can reduce the thickness of the part, or how can improve the component quality, so that I can understand if I can modify my design to be more compact, whether I can consolidate different parts in the particular part of the assembly. And lastly, how can I get to the market sooner? So one of the key things that I mentioned earlier is, using simulation, you're actually reducing the time by removing the aspect of physical prototyping. You might as well do a physical prototyping in the end at some point, but you can understand different designs, different materials, different loading conditions beforehand on your virtual simulation environment before actually jumping into a physical prototyping. So the amount of time you spend and cost you spend on physical prototyping can be reduced significantly. And like I said, up with upfront material testing, you can do different tests for different materials, different behaviors, and different situations. And as I mentioned earlier, it's where it's getting through this different design iteration. So if I can see if I can change certain aspects of the design, certain thickness of the part, and understand how the part is going to behave before actually having to manufacture the part. And with simulation, you can also understand how you can simplify your design safely, where you can reduce the number of parts, you can make your assembly simpler, you can basically, that all not only helps reduce the complexity of the part, but also helps in reducing the cost in manufacturing as well as testing and prototyping. Now, coming to the simulation products that Autodesk has to offer. So for mechanical simulation, there's two main products that we offer. I'll talk about both. The first one we have is Autodesk Inventor Nastran. So Autodesk Inventor Nastran is part of the product design and manufacturing collection. So if you are a subscriber of the product design and manufacturing collection, you get Autodesk Inventor Nastran for in as a part of that collection package. You can install it, and basically it uses Inventor as the user interface and Nastran as the backend solver. Now, if you are inside Inventor, you can go to, once you have installed it, you can go to the environment section and you can see Autodesk Inventor Nastran there. If you click on it, it will take you to the Inventor Nastran environment inside of your Inventor user interface. Now, what is Inventor Nastran? So it's a general purpose finite element analysis software, which is embedded inside Autodesk Inventor. The key purpose of having Inventor Nastran within Inventor is, first, you have a low cost to benefit ratio. You don't have to purchase a separate simulation software for it. It's embedded within your CAD environment, so you can run your simulations on your CAD in your CAD environment, make design changes, get them into your get them to run on your simulation environment inside your CAD environment. And with Autodesk Inventor Nastran, we have a lot of advanced simulation capabilities. I'll talk a little bit more about those in the coming slides. And most importantly, the backend or the solvers that we use for running this finite element analysis are Nastran and the explicit solvers. These are worldwide trusted simulation solvers available with us. Now, jumping into the capabilities that we provide with Inventor Nastran. So with this product, you're basically get some basic analysis capabilities. So you want to do some really quick basic analysis, or like linear static or normal modes or buckling, where you want to understand just how much of load would affect the deflection of my part, how much of stress it would cause in my part. Really quick, understand how the part would behave in different natural frequencies. So really getting a quick, easy feedback on how my part is going to behave in certain loading conditions. Or it could be a structural load, it could be a thermal load with linear steady state and linear steady state heat transfer. You can also do composites analysis and as well as thermal stress analysis. So different types of basic analysis, which mechanical engineers typically do a quick simulation right after they have designed a part to understand some of the basic behavior of the part. So they can understand how different loading conditions and different boundary conditions are affecting the part, and they can take some design decisions or make some design changes accordingly early in the design process itself. Now with Inventor Nastran, you get the capability of doing the analysis with your assembly itself. So you can define the loads on a single part as a part of the assembly. It will also take into account its contact with different other parts, and then see how the part interacts with the loads as well as with the other parts of the assembly. So really quick and basic capabilities are available with the Inventor Nastran product. Now jumping into the advanced capabilities, that's where a more of an advanced analysis comes into picture, where you have more complicated loads, more higher loads that affect the part in a much larger way, where you have analysis capabilities like nonlinear statics, nonlinear steady state, and transient heat transfer, then vibration and multi-axial fatigue, as well as response to different frequencies. Again, we also have capabilities like linear, nonlinear, transient response, as well as capability to simulate nonlinear and hyperelastic materials. Also, we have through our Nastran solver capability to simulate impact analysis and drop tests. Now, these are the more advanced analysis where not only you are looking at some kind of an advanced loading or boundary condition situation, but also the behavior of the part goes into a much advanced state where your material could be required to simulate the nonlinear part of its material curve, as well as hyperelastic side of the material behavior. So again, like with Inventor Nastran, you can set up these simulations in your CAD environment, have those different boundary conditions and different material behavior defined for this part that you're trying to simulate. Now, coming to what capabilities we are currently working on. So at this point, with Inventor Nastran, we are about to release our 2021.0 version will be around the Autodesk global launch timeframe. So sometime by end of March, we'll be releasing the 2021.0. With this release, we are bringing in two new advanced analysis types. Explicit dynamic analysis, where you can simulate transient behavior of a part where you have, or an assembly where, as you can see in the video running besides, its simulation of a buckle getting inside and how it would break. So it's basically simulating how a material would behave in a transient or a time-defined conditions. And then you have also, we are also with that, we are bringing in the capability to run quasi-static analysis. Now, quasi-static analysis is kind of similar to an explicit or an explicit dynamic analysis, but the simulation itself or the process itself is so slow that we don't take into account the time aspect of the analysis. So basically, it's pretty close to a nonlinear analysis where you have a different, we have similar loading conditions as your dynamic analysis, but time factor is not taken into account. So we basically neglect the inertia of the part. Also, apart from these two analysis types, we are also making some high priority bugs and improvements based on the feedback that we get from our customers, from our support teams, as well as our channel partners. They identify some of the key gaps in our workflows today, as well as some key bugs that might be causing certain issues for the users. So it's really good to address those bugs with our every release, as well as we have some post-processing improvements coming with this release. Now, going ahead and future releases of Inventor Nastran, we are continuing to address some of these high priority bugs and improvements. Mainly from what I have seen in the slides earlier, we have a lot of capabilities already available within Inventor Nastran product. So a lot more focus for us now going ahead is to address the gaps and workflows, gaps in the workflows that are causing issues for users to run their analysis smoothly or in a much more simplified manner or much more easier way. So we are trying to make it better for the users. So it's a lot of our focus is more on getting those workflow gaps and improvements in our future releases. Now I'll move on to the second. Oh, so before I move on to the second product, one quick resource that I wanted to highlight is our online help. Now, Inventor Nastran is a very well documented product. So if you are new to this product, you want to understand what it can do, you can always go to the online help. We have anything and everything available there that can help you guide through the process of understanding what Inventor Nastran can do, how you can set things up. So we have quick start tutorials, basic tutorials, advanced tutorials, as well as we have a self-paced training. So you can, it's very well documented with videos and example problems that you can use and refer to get a good understanding of how Inventor Nastran can help you in your product development process. Now moving to our second product, Fusion 360. Now Fusion 360, if you are a Fusion 360 subscriber, or if you're a PD, Product Design and Manufacturing Collection subscriber, you have access to Fusion 360, and with that you get access to simulation capabilities inside Fusion 360. Now, again, just like Inventor Nastran, even Fusion 360 simulation is powered by our Nastran and explicit solvers. And most of the capabilities that you can see listed here are similar to what you have access to in Inventor Nastran products. The only big difference between Fusion 360 simulation and Inventor Nastran simulation is the type of user we intend these different products to. So with Inventor Nastran, based on the level of detail and level of fidelity you can get into a simulation setup, it's more targeted towards the advanced users who are much more familiar with simulation process, who are more familiar with setting things up in a simulation, who understand more in depth of what the simulation capabilities they can work with and they can get the benefit from. So it's geared more towards the structural analyst or more advanced mechanical engineering users. Whereas with Fusion 360 simulation, what we have done is we have simplified the simulation process such that even a designer can quickly be able to understand what simulation can provide him and be able to set things up inside of Fusion 360 and immediately run analysis on it. So as you can see, we have similar capabilities that we had in Inventor Nastran. We have linear static stress, modal, thermal stress. We have something different called shape optimization that you can use to optimize different shapes or basically reduce material, improve the stiffness of the part. So that is a different analysis type that we offer with Fusion 360. It's mainly, again, geared towards the designer because as a designer, if I design the part, I want to make it more simpler or optimize it for certain behavior, certain structural load, then I can use that. And then I have advanced capabilities like buckling, nonlinear static stress, and event simulation. And recently, we have also added electronics cooling. So we are bringing in more of the CFD aspect into the simulation workflows and works inside of Fusion 360. With Fusion 360, you get the ability to solve it on the cloud so that you don't have to use your machine to run high computation simulations, as well as you get capabilities like Simplify Workspace and Compare Workspace. Simplify Workspace is where you can simplify your model, simplify the geometry, simplify your assembly so that you can do a better job of setting things up for your structural simulation. And in Compare Workspace, basically you get the ability to compare different simulation uh, runs, simulation load, different load cases that you probably set up, as well as different boundary conditions that you have set up, as well as different materials. So there's a lot of capabilities that you can get with Fusion 360 simulation. Now, as I mentioned earlier, the whole idea of putting simulation inside of Fusion 360 is to make it easy for ease of use for the non-expert users. So if I'm a designer and I want to understand some basic behavior or some early behavior in my simulation on my design of my part early in the design process, then I can use simulation real quick and easy. And what we have done with Fusion 360 simulation is we have tried to make it more of a guided experience rather than the user having to have knowledge upfront to run a simulation. So with once you enter the simulation, if you're trying to create a new study, it can help you pick the right study type by helping you pick the right question. So we have listed different questions here. So if you have a particular question, like I mentioned, whenever you're entering simulation, always ask, what are you trying to solve? Now, we have put some sample questions in here that can be same or closely matched to the questions that you are trying to answer, and we will help you pick the right simulation type. And as you enter the simulation workspace into a study type, it will also guide you through the different steps which with what you need to set up during the simulation setup process. So you need to set up your material, set up your loads and boundary conditions, and then they basically solve it. So it's a really simplified, guided process for the non-expert users. Now, as I mentioned, we have a simplified workspace that can take you to the a separate workspace inside of simulation where you can basically simplify your model to take into account or basically simplify certain features that you may not want to uh, simulate as part of the simulation process. Mainly, it is used to remove really small minor features which you know you are not going to affect your results, as well as remove certain parts of assembly that you know are not going to interact with the other parts that you're actually trying to simulate. So the Simplify workspace helps you reduce the amount of computation that would be required. So if you remove certain small features, it will simplify your mesh. It will not mesh your part too fine so that it will, if the mesh is too fine, it takes a lot of time to compute. So it really helps on defeaturing your model, as well as with simulation workspace, you also have the ability to create a separate simulation model itself. So you can actually modify your designs to run different design iterations in the Simplify workspace, and then take it to your simulation study and run it run the structural analysis. With that, with different designs that you simulate, you can then compare those results and then understand which design suits better needs. Now, one good thing about Simplify Workspace, if you make a design change, it does not actually affect your original design. Your original design in your design workspace remains the same. But if you do come up with a design that actually is better than your original design, you can always export that new design and bring it in your design workspace. With Simplify, we have also added the capability to connect with our specialized products like CFD and Moreflow. A lot of our CFD and Moreflow users actually use Fusion 360 for simplification of their models as well as to run some structural analysis if they want to on their models. So when you have Moreflow or CFD installed on your machine, the add-in that connects Moreflow or CFD to Fusion 360 is automatically installed. You will see those add-ins in your Simplify workspace in Fusion 360. And then you can push your models from Fusion to CFD to do advanced analysis, or from Fusion to Moreflow to do advanced analysis. With Moreflow, you have an additional capability where you can also bring a model from Moreflow to Fusion and then take it back after you have done some simplification or CAD repair or any design modification. Now, what we are working on currently in Fusion 360, again, just like Inventor Nastran, we are also working on explicit dynamics inside of Fusion 360. We call it event simulation in Fusion 360. It's basically used to run short duration events, uh, also with materials and highly nonlinear behavior. We are use event simulation for large loads that would cause large deformation, and if it involves large motion, as well as impact test or drop test like snap fits, etc. So this is currently available as a tech preview for the users. We are getting pretty close to commercializing this by adding a few more capabilities into our existing event simulation workflows. The other thing that I mentioned that we have been working on electronics cooling. So that's where you can basically simulate the thermal and flow behavior of your circuit board. So if you are a designer who uses a product like our Eagle product, or now we have added the capabilities of Eagle inside Fusion. So if you're using Fusion 360 to create circuit boards and create different parts within the circuit boards, you can basically simulate the entire circuit board assembly in Fusion 360 for any thermal and flow behaviors. So one good thing about using electronics cooling is we have implemented geometry tolerance in there. So you actually don't need to simplify the model. So you can take your model as is into simulation, and without removing any fine features or any minor features or many minor parts that you know won't affect your simulation, you can actually don't have to go through the simplification process. You can just run it as is, which also brings to the next point of setup automation. Since you don't have to simplify, most of your simplification work is not required, as well as going through the setup, we have automated that process as much for the users. Plus, we have the design integration. It's an enhanced experience that we are bringing in, where you can have your PCB model open as well as your electronic simulation open on the Windows side by side. And then with this particular simulation type, we are introducing a new visualization experience. As you can see on the right hand side, it is slightly different from what you saw visualization experience, or you might have seen as a visualization experience for the structural simulation. This is where you can see how different parts have different temperatures, and how each of a part can have its own critical temperature, and you can identify which part will be subject to higher thermal loads, and that might affect the part on a larger scale. Plus, as you can see the image below, you have the ability to simulate the flow of air. So you have your circuit board and you have a fan in your assembly that is going to blow the air through the circuit. Then you can understand how the flow pattern would be through the different line. This is similar to what we have as a visualization for flow simulation or thermal simulation, but we have enhanced the user experience to make it more simplified and easy to understand for our users. Now, as we go ahead in Fusion 360 simulation work, again, like I mentioned for Inventor Nastran, we are identifying different workflow gaps and trying to understand how we can make it a better experience for the user. Also, we are also currently exploring the ability to bring in injection molding simulation instead of Fusion 360. So that's under a more of a conceptualization and ideation phase right now. So I don't have a slide for that here, but that is something that we are currently working towards. Now, just like Inventor Nastran, even Fusion 360 has an online help that is very well documented. You have a lot of videos and tutorials, as well as uh, self-paced learning that you can access and try to get familiarized with the product. So if you are new to Fusion 360, we have getting started tutorials. If you're transitioning from a different CAD system to Fusion 360, we have tutorials, separate specialized tutorials for those as well. So a very again, Fusion 360 is a very well documented product, so you can understand what simulation can do, what capabilities you have, how you can use simulation inside Fusion 360 through our documentation as well as self-paced learning. With that, I'll end my presentation. I appreciate all of you listening to my presentation. Thank you so much.
Yeah, thank you so much, Rahul. And we'll switch to Michael's presentation in a couple of seconds with the focus more on learning aspects. But before we do that, I wanted to thank you, of course, and also kind of confirm my understanding and for everybody here of options available to everyone. Like the first decision-making factor is what is available to you. And in many cases, we don't even know that there are a lot of tools that we actually have access to through subscription and product design and manufacturing collection. So good first step is to see what's available to you through Autodesk account. This is kind of single destination. So I just sent the link to Autodesk account where you can see your entitlement, right? What products and services you have access to. This is kind of first thing. And second thing is probably once you understand what's available to you, you can decide, okay, Nastran and CAD, it's available inside Inventor. This is the environment that you currently use for design and can simulate products right inside your design environment. Option number one. Option number two, you go to Fusion and you explore some of those extra capabilities available in Fusion, and also Fusion is pretty well connected with Inventor, so this is another option for you. So, but step number one is just makes sense to take a look at what is already available to you. So, am I correct, Rahul?
You're spot on, Anton.
Mm-hmm. Excellent. All right. So with that, let's switch to Michael's presentation. Hey, Mike, can you hear as well?
I can.
Excellent. So let me make you a presenter, first of all. And secondly, Rahul mentioned about learning content and a lot of tutorials available to everyone, right? And that is absolutely true, and I use them a lot personally. But there is something, right? There is a reason why we, and not just we, everyone writes books about simulation, creates courses. So what's that reason? What's that missing? One extra step that is missing in tutorials? Like what motivated you to create a big e-learning course?
Yeah. So that was definitely a guide whenever this content was created, right? As Rahul pointed out, there is a lot of content that currently exists, and I think that's a good thing. There are, tutorials that everybody can access either for Fusion or for the Nastran product. There are the help files, right? So you can go to the help and you can read about something. You can go through tutorials and you'll see the steps about how to apply something with the software. What we really strove to do with this content was add in the answer to the question why, right? Because sometimes when you go through tutorials, one of the potentially frustrating things about it is it says click this button or enter in a value of 0.5 in this field, and then it moves on to the next step, and you're left wondering why exactly you did that. And I understand from a creation content that sometimes we try to streamline the tutorial so that somebody can get through it quickly, right? You're not investing too much time to go start to finish on a tutorial, so that you can actually accomplish something with that tutorial. But we really strove to go a level deeper here with the simulation learning path, and explain not only what options are in the software, but why you might do a certain step within the software as well.
Excellent. So maybe it's a good intro or transition into your main presentation. So Mike, why don't you start by just saying a little bit more about you and how your journey in simulation started?
Sure. You guys are seeing the main screen?
Yes.
Okay,
Yeah.
perfect. All right, thanks. So yeah, just a little bit about me and my history, how I came to work with simulation for so long. Um, so I went to university for mechanical engineering, and fortunately for those of us who attended that university, not far down the road is a locomotive business, and I went and co-op there. So that was my first experience with some engineering related responsibilities. And I have a snapshot there of the Norfolk Southern, one of my favorite paint jobs for a locomotive. So of course they come out of the factory with whichever livery, the locomotive is being sold to. So I have a good appreciation for those ones. Even still, my family's probably sick and tired of me now pointing them out as we go down the road if we happen to see one. Um, they can certainly identify them, I think, as well as I can at this point. And then after college, moved back to the Pittsburgh, Pennsylvania area where I'm from, and went to work for a company that makes steam turbines. So you can see an image of that there in the upper right-hand corner. So I worked there for a while. And then from there, I moved to a company which was much closer to home, and we started making sheet metal hydroformed products. So that's what you see in the lower left-hand corner. We made a lot of products very similar to what you see there. And they had different applications, some agricultural, some medical applications. And we started getting into the automotive business. We started with a single product that we supplied to an automotive company for a specialty vehicle. And then from there, they started seeing under hood applications for a lot more of their vehicles. And it was at that point that they asked us to do some simulation, some validation. And there's a couple of reasons there, right? So obviously with the bellows there, it needs to be able to deform a certain amount. We also need to avoid certain frequencies that the vehicle might experience. So we were doing some natural frequency analysis. But initially, we weren't doing any simulation. It was on the shelf, 3.5-inch floppy disks. We had it available to us, but we weren't doing it. And so my boss came to myself and another one of the engineers there, some younger guys at the time, and said, "Hey, are you interested in getting involved in doing this?" Of course, I jumped at the opportunity. And then eventually I went to work for the company of the simulation product. So that was about 20 years ago. In total, I worked for that FEA company for about 10 years, and then it was acquired, became part of Autodesk about 11 years ago. So that's a little bit of history of how I came to be part of the support organization. Okay. And going back to the question that Anton asked early on, so what we are talking about here is the mechanical engineering journey, the simulation learning path. And again, what we wanted to do was devise something or create something that was a little bit different than what exists currently out there for the product. So in the first bullet point there, we really had 3 key objectives to keep in mind when we created this content. And the first one was that we wanted it to be readily accessible and readily digestible, right? There are different, of course, levels of information that you'll find out there. And again, there's a lot of it, and I think that's a good thing. And I hope this is certainly a useful level where we went. You'll find certain videos that are really short sometimes, right? Minute and a half, 2 minutes long. And those are great to let you know that something exists in the software. It's there. And at that point, you know you need to learn a little bit more about it. And then at the opposite end of the spectrum, you'll have things like technical white papers, which tell you about the formulation of different types of elements. And that's good too, to help deepen your understanding of finite element analysis. But we decided that where we wanted to go was kind of right in the middle. Here are different tools that you're going to want to use within FEA, and this is how you use them. And the second bullet point there, I worked with a colleague of mine, John Holt, who I've worked with for the past 20 or 21 years. He works in technical support, so if you've called in with questions on Nastran or Fusion, you very well may have conversed with him as well. And we looked at each other and we said, we've got a lot of experience, a lot of history between us from multiple sources, and that comes from product support, being on the phones, answering emails, and then also in classrooms, right? We've both done multiple training events, numerous training events. And there are questions that come up in a one-to-one interaction and meeting different people from different parts of the industry. And so what we wanted to do was to bring that experience to this course as well. What are the most common questions that we hear when we get to a training environment? What are those questions that come up on day 1, day 2, day 3, and incorporate those? And again, point B there, we wanted to keep in mind the why. So always when I was creating this content or when I was working through a video, what I wanted to do was answer the why. And you'll notice that in this content, what we have is some written documentation about what exists in the software. So we might talk about the types of loads that are available within the Nastran and the Fusion product. But then when I go to the video demonstration portion of the content, it is very much free form instead of a scripted video. And the reason that I did that is because when I teach, certain things come to mind and I'll expand upon a certain topic. So I wanted the videos to be the same way. And then lastly, just a note, I did use Inventor Nastran as far as the demonstration videos are concerned, but the information itself should be generally applicable to FEA. So as you go through this content, if you do take it, which I would certainly encourage you to, what you'll find is that the format starts with some written content. And when the content is written, it should apply to either one of the products that you decide to utilize, or even a different FEA package entirely. And then again, when we go into the video content, you'll note that it is within the Inventor Nastran product. The only reason I did that was because it happens to be the one that I probably address the most questions on these days, as well as the suite of functionality. As Rahul pointed out, there's a lot of functionality within the program, so it allows me to go into different areas. So what exists currently today as far as the simulation learning path? Well, it's changing rather rapidly. When I created the slides for this the other day, which I think was Monday or Tuesday, there were 4 pieces of content or journeys that you could go on, courses, and that was what can I simulate, choosing the analysis type, which, similar to the slides that Rahul had highlighted with the different types of analyses, that particular course will talk about all the different types of analyses and go into a bit of detail on them. And then, of course, there's a video which will walk through a couple different analysis types. And then we have preparing a CAD model for FEA. So what are different types of things that you might want to do before you actually push that CAD model into simulation to make your life a little bit easier. And again, that's pulling on the experience over time, some of the things that might trip people up when they get into simulation. And then we have element types and meshing within FEA. So of course there are a number of different element types that can be used in FEA. So this one will cover things like brick elements and shell elements and beam elements. So we'll explore those. Again, all these in text and then video format. So we'll read a little bit about it, and then we'll show you how to do it. And then there is loads and finite element analysis. So expanding the different types of loads that are, again, generally available, and then showing you how we can apply them in different ways. So those were the 4 that were available, and then very recently, overnight here within the last 24 hours, 3 more have opened up. So I had these 5 listed as on deck. So these 5, as far as my content generation process, were all done. And they had yet to be released, but the top 3 here now are also available. So you can get to constraints in finite element analysis, contact between parts. Contact is always a big topic for people within simulation, right? When you're just getting started with FEA analysis, how do I deal with the interaction between parts and assemblies? What are the certain things that are going to trip me up potentially? So we highlight those sorts of things. And then of course it's kind of specific. Different finite element analysis programs all work a little bit different about how the contact is defined. And the options that are available for contact. So we talk about those in that course. And then connectors. Both Nastran and Fusion 360 both have different types of connectors that are available to you. So we'll talk about things like the rigid body connectors, in spring elements, things like that. So that one starts to get a little bit outside, what might be foundational information. Connectors are maybe something you don't use every day, right? But something good to know about. And then we get into material models. And I really had 2 different ways to go with this, right? We could really deep dive on a specific material model, such as the hyperelastic material models. We could do a deep dive on the nonlinear material models. And my thought here was we could certainly do that further on down the road, depending on what we hear from the community is being a real need. So if we hear feedback from a lot of people that, hey, yes, I'd really like to see something specifically on hyperelastic materials, certainly happy to generate it. This one is a little bit more of a higher level overview to expand and expose the different types of material models. And as far as the actual example that I go through in that one, we do a nonlinear material model because probably I would say most people start with isotropic material models. And then once I get familiar and a little bit more comfortable, then the nonlinear is probably something that comes up next. So that's what we did there. And then lastly, all these other ones, all the preceding ones here are about setting up the model, applying the appropriate aspects of the setup of the FEA. And then of course you're going to run the analysis and you need to look at results. So the last one within the series currently is results interpretation. So what do we want to look at? What can we look at? And then how do we do some unique kind of things like graphing results and creating the plots and the images that we want to see for the results, that we can convey those results to other people, which is really the ultimate goal of the analysis. So those are the current list of courses that we have available, and certainly we would love to hear feedback from all the users so that we know what we can create next. We don't plan to stop right there. Okay, that's everything that I had on that content.
Excellent, Mike. Thank you so much for this presentation, and also the extra information about the, some of the whys, right, and the inspirations for the content, because to me it was personally challenging. I am a mechanical engineer, but kind of more on design side, so I'm not necessarily an analyst. And it was very difficult to understand some of the concepts with tutorials because it was exactly like you described. Put this number into the field and press simulate. I was like, okay, good, I got the result, but why was it that
Personal
way?
pet peeve.
Yeah, so it resonated a lot with me, and I hope with the audience as well. So let me quickly summarize what happened here and kind of next steps, right? But in the meantime, please ask your questions, and Mike, if you could take a look at the list of the questions, that would be awesome. Yeah, again, this is virtual meetup, so this is live. Please ask your questions because I mean it's such a great opportunity to have both representative of product team and one of our best engineers on the same call. So please type your questions in questions panel. And I wanted to drop a couple of notes, key takeaways and next steps. First step, of course, like to see what's available to you already, right? What products, go check your Autodesk account, talk to your admin. I will post the link to the courses that Mike just spoke about. We have 7 and 2 more are coming. It's changing, right? We're publishing them quickly and you can see more and more courses almost every day. But the link is already available in your chat window. So go check them out. And all you need is to have the same Autodesk ID. Every Autodesk user has it. It's the same that you use for Autodesk account. And you can access it for free. Then we have more courses, not only for simulation, available on the same portal. So starting from 2D design, transition to 3D, CAM, simulation, sustainability. So a lot of good courses for mechanical engineers specifically. They're not so much focused on one product. It's more about like kind of cross-product workflows and some of the whys. So what Mike spoke about. And finally, I highly encourage you to register to the next mechanical engineering meetup in April, second Thursday of April, and we'll have great speakers from the sustainability part of the business. So if this is the topic that resonates with you, that you're interested to see like what's going on in sustainability, what's Autodesk point of view, we'll have great speakers from sustainability team. So register to the next meetup. And how to do it, I will also post in the chat window. Don't miss the opportunity to join. With that, so let's take a look at the questions. We have a couple of questions that we wanted to address. Do we have any unanswered questions?
Looking here. Paul asked the question about how you account for glue and staples on a plywood structure. How much time do we have?
We have 2 minutes, so we could probably take it offline if it's a long answer.
Yeah, to be honest with you, Paul, from the support aspect, I would want to have that discussion as a deeper discussion in a support call or via support issue, because what's going to happen is we could probably think of multiple ways to do that, and I see potential drawbacks to some or challenges to some, you know what I mean? So I think that what we would want to do is say, what would be the, what are you looking to get out of including any of the items? And then what I would do is propose a solution, and then, you know, it would probably be more of a back and forth discussion, I think. But yes, I think there would be ways to accommodate. It's just which approach we would take would depend on exactly why.
Yeah, okay, excellent. So the recommendation here is to reach out to support and connect offline.
Yes,
But in the meantime, yeah, I wanted to show you the actual website since we're live, right? So this is the meetups that we have here and the courseware available to us. Yeah, so this is the course that we have from Mike. You see, we have 7 courses, in fact, and all you need is your Autodesk ID. So you just sign in with your Autodesk account. This is me. Hopefully it will work. Oh, no? Okay. And here you are. So it automatically picks up your Autodesk ID and you can start taking courses. So it keeps the track. It gives you the information about what you finished, where you are at the moment, and also it is connected to virtual community meetups that we discussed for mechanical engineers, so don't miss them. And important follow-up ask for all of you is please let us know how we did, if the session was valuable or not. What other topics would you like to hear about as a part of the survey that you receive immediately after the webinar closes? Please provide your feedback so we can improve going into the future. But with that, I hope you enjoyed it. Huge thanks for all of you for joining, and thanks to both of our presenters, Rahul, Mike. Thank you, and have
Thank
a
you.
good rest of your days.
Thank you,
Thanks.
everyone.
Thank you.